Yeah, so we're back. What's called P is maybe preliminary. And it's like review. We did a P7 at the beginning of the semester. Like, how do we solve basic equations that you just to kind of warm you up? So P9 is a similar thing. I'm just going backwards. So it's fresher in your mind to do this other section, which is in I think it's 2.7, chapter 2. We go jump over to another chapter to pick up inequalities. Anyway, these are the 4 inequalities that we're going to deal with. There's a 5th one. Okay, inequalities, it kind of means not an equal sign, not equality, not equal. So not equal is I consider another inequality, but we will not deal with this one, only these 4. And a little reminder, again, multiply, divide by a negative number, switch the direction of the inequality symbol. So again, a little baby problem. I recommend, highly suggest, I'm not going to force you to do this, but I'm highly suggesting so that you avoid the common mistake somewhere. I highly recommend that you get the variable or keep the variable on the left-hand side each and every time. There's a reason for that. Most of my algebra students, they make the common mistake when they have the variable on the right-hand side. Here, most of you, if I had a plain old equation that said, 5 equals 3x, and you'll say, but Jeff, I can just divide both sides by 3 and be done. You're right. With an equation, you'd have 5/3 is equal to x, but it's also true that it's x equals 5/3. It's as if I took this equation and mirror image it. So the equal sign, think of it as equal sign, looks like this. Okay, flip the direction in equal sign when I go this. Okay, still looks like an equal sign. Still looks like it. Students that will have the x here, and they go less. Okay, so they do like this one, for instance. And they say, what's the big deal? It's a good answer, but you're going to have to graph where all the answers are. And that's where the mistake is going to be made, because you look at this as left to right. So you're going to make your arrow point to the left where you think all the answers are, and that's wrong. All the answers have to be bigger than 3. 3 is the smallest, bigger than 3. So to avoid that, if you did this, to avoid that, flip it around. You can do that. Flip this around, and then you can do this graph, which says, here's my 3 parentheses bigger, all the answers over there. You'll get it right. So I'm going to start right off, and I'm always going to get the variable on the left-hand side to start off with, so I don't have to deal with remembering that. So add 5 to both sides. So 2x is greater than or equal to 6. Divide by +2. So if I divide by +2, no flipping anything. So I'll end up with x is less than or equal to 3. That means I got a lot of answers to the original, and all the answers could be anything less than 3 or even equal to 3. For instance, hey, how about 0? Zero's true here. So if you go up to the original, check it. 2 times 0. So -5 less than or equal to 1. That means 0 would work down here, 0 worked up there. So how do you either display or explain your answers graphically? That's what this says here, is use a graph result. Then you go over here, here's 0, here's 3. Answers are all this direction. And notice up here, I put a parentheses above because there's no equal. Since there's an equal here, oh, I got it going the wrong direction. My mistake. Talk about making a mistake, and there I just did it. That was very careless. Okay, I don't know how I got to thinking bigger than. It's less than or equal to 3. That goes left. See, 0 is one of the answers, so it should have gone this way. So apologize. You're going to make a mistake too at some point in time. Just try to minimize the number of mistakes. Okay, and then put a bracket because the equal sign. Oh, and this whole interval notation, You learned that, well, if you took SRJC classes, you absolutely learned it before this class. Absolutely, guaranteed, 100%. Every instructor here, every textbook that we use. Now, if you came from a high school, yeah, I can't say that you guaranteed that you've seen interval notation. And if you came from another college, I can't guarantee what you saw. So I'm just going to remind you, the brackets and parentheses are included in this interval notation. And there are two numbers. There's a small number and a big number in interval notation. And you use parentheses and brackets to indicate. So if I look at the graph, and I always start with the graph, the textbook might say, do interval notation, then graph. You graph first, then interval notation. It won't make a difference, but I think your answers come off the graph a lot easier to see. So do the graph correctly, like I fix this. Smaller number along here is always to the left, of course, smaller. So it's way over here in outer space. That's negative infinity. This thing's pointing forever to the left. So interval notation, the smallest number is negative infinity. And we agree you never put a bracket on infinity, never, because you don't know what it is. So it's always a open parentheses, and then you comma, this is just the notation we use. And then you put the number 3 here, and then the bracket follows from the graph, means you get to include it. So that's called interval notation. Set builder notation, which I'm not asking. Oh, here it is. I am asking. Set builder notation. Set builder notation, SBN. Squiggle, squiggle, line. Now, maybe some of you, even SRJ students, some instructors may bypass the set builder notation. My beginning algebra textbook does it, so I use it. But it's not as commonly used as this notation now in higher level mathematics like you're taking. But I'm still going to show it to you because you're going to be asked about it. So always use the squiggles, that's set notation, set symbols. That bar to the left is indicating the phrase like such that. And I guess such that is the best. So you're saying, hey, where are all my answers? Well, all my answers are dealing with the variable x. So you use the same variable over here on this left side. Okay, what are my solutions? Well, all the solutions with the variable x are such that such that. Mathematics likes a lot of symbolism. Such that. I've heard it such as well, such as. I'll take either one. So such that. And then you could say some textbooks or instructors would say, which makes sense. Well, such that it's real numbers. You got to make sure, hey, it's real numbers. You guys would say, oh, okay. I better say that because there's a bunch of other numbers that aren't real. And you guys know what those are because we did it in this class. Imaginary. So not imaginary. So let's put the real, such that it's real. Double-legged R is a symbol for real numbers. Or you can write the phrase real numbers. Such that, and then we go here, maybe a comma, and then you go x is less than or equal to 3. So this is a version of the set builder notation. There's multiple versions here that could be acceptable. There's only one answer for this. That's good. That's it. I'll bet you on the multiple choice test, final exam, I could just say, hey, what's the interval notation for the solutions? I could write this with a parentheses on the 3 and catch a couple of you because you're getting sloppy. You're not remembering equal means a bracket. I could reverse this and have it go like what the mistake I was doing, like 3 to infinity accidentally. There's lots of ways, versions of the answer here. Of course, there's only one version that's right. So just be careful. Okay, so going to do a few of these. I'm not going to do them all. Bonnie, you get to pick 2 of them. Which 2 would you like to, if someone comes after class and meets with you, you'd work through it?
I don't really have a preference, Jeff.
Okay, I'm going to give you these 2 right here. So Bonnie's going to go do those 2, and I'll do these. All right, now I said at the beginning today, about 15 minutes ago, I am targeting getting the variables on the left side, not the right, the left side of the inequality. So I'm choosing to move the x first, which is a subtract x. Subtract does not have you flipped the direction of the inequality, not subtract. It's multiply, divide by a negative number. So the sign here remains. What's on the right-hand side is 0. This is x plus 4. And now I move the 4 over to the right by subtracting. Again, don't change the direction of the inequality. And then what you do is do the graph first, is what I suggest. Negative 4 is over here. Bigger than, parentheses, goes to the right. I'm just going to do interval notation from now on, not the set builder. Interval notation for here would be parentheses, line it up, negative 4, comma, all the way to infinity. You can see what's going to happen when Bonnie does this one. Hint, hint. She's going to get rid of the negative by multiplier dividing. Hint, hint. Not to Bonnie. She knows what she's going to do. But the rest of you, flip the direction inequality. You're going to have to flip it. And Bonnie, what I would do, which I'm going to do right now with mine too, is test. You know, just pick a number on the number line. Like here's my number line right here. I'll pick 0, you know, because it's over here. I'm going to test it in the, or check it. That might be a good idea. This is a hard one to check, Bonnie, but that's still a good one to check. Pick a number on the number line for them and go through the check to make sure that it works in the original. So I'm going to check 0. I'm going to check x equals 0, but I always check it in the original. So I go 2 parentheses 0 plus 4. Is that bigger than 0? Is 4 bigger than 0? Yes, check, check. So then the picture is good. And if the picture is good, and I feel confident about the inequality, then that inequality is good. This would be a good one to check just because with the negative, Bonnie, that's all I'm saying is, on occasion, I wouldn't suggest this to you, Bonnie, but on occasion, like this one, I might have, if I did this, I might have forgotten purposely to switch the direction and then looked at the graph, picked something and found out it didn't check. So that means as a student, I did something wrong and probably forgot to switch the direction. So, okay, this one here, a bit of work distributing. So you got 18, subtract 24, 10. This is easy to make a mistake, right? Oh, that's 7. I mean, it might, you know, see 5 and 2, 7. That's easy to, instead of 10, it's 10. But that's an easy mistake. Once you make a mistake and you don't catch it and it follows all the way through and everything else is like great and you understand the concept at the end, it's a good idea if you have time on your final exam, which I think you will. Think about it. I'm giving you 2 days, 48 hours, 2 days. And if you're targeting a certain letter grade and you're trying to do your best, this is places that I might check my answers somehow. There's ways of doing most of all your problems. So you have, I think it's 50 problems for your multiple choice. I think it's 50. 2 days, 48 hours. That's a ton of time where my in face-to-face class, I've said this before. Okay, don't get so passionate, Jeff. Excited. Face-to-face, 2 hours, 45 minutes, that's it. And for a 50 problem multiple choice in my math 25, on average, most of my students get it done. I don't know if they don't necessarily get them all right, but get it done maybe probably under 2 hours on average, under 2 hours. You've got 48 hours. So you figure out when you take it and you can step away. You know that. You can start, I'll do the first 10 and then I'll come back to it tonight. Checking your work. You will have time to check your work. So I didn't make a mistake here. Minus 15M doesn't look like a mistake. Minus 28. Collect like terms, nothing over here. So still 18 subtract 24M. Less than, okay, combine like terms, negative 18, I think. Subtract 15M. Excuse me. Then I'm going to move the 15M over here by adding it to both sides right away. Move the M's to the left-hand side. Okay, I've got 18, subtract, let's see, I think that's 9. 9M less than negative 18. Okay, subtract 18. Negative 9M less than negative 36. Divide, warning, divided by negative 9. Warning, Will Robinson. You haven't, unless somebody's of my age, they'll have no idea what I just said. I don't know if there's anybody my age or in my Will Robinson. Anybody know why I said Will Robinson?
Lost in Space.
Hey, all right.
There's a new one out.
There is, and it's very good.
Yeah, it's good.
So yes, the old school Lost in Space, which was very dorky, back sets. But I loved it as a kid. Yeah, and that was a phrase that the robot would say, "Warning, warning, Will Robinson."
Hey, Jeff, can you check the sign on your 18?
I will do that. So I'm subtracting negative, like this 18.
Oh, you were moving. Okay, I didn't see which side you were moving it to. I thought you were moving it to the other side. My bad.
That's okay. So it's good to check me. I'm going to move the 18, this 18 to the right, not this 18
Yeah.
left. So
Okay, that's where I got confused. Okay.
Easy to do. Here's a mistake, and mental arithmetic, you can get yourself into trouble. Before I even do that, look at, I see 18 and I see minus 18. I'm thinking 0. All of a sudden I make negative 9M less than 0 or something like that. Make easy. So be careful. I'm going to check, because if you did that, it probably would end up being a problem. I'm going to check. If this works, then I'm pretty confident. Switch 4. Okay, so anything bigger than 4, how about 5? 5. Bigger than 4, 5. I'm going to try. Check. X equals 5. Let's see. Bigger than 5. So I'll go into the original. Oh, you don't know what I'm doing. Sorry. Okay. So I'm checking X equals 5 in the original and then simplifying PEMDAS. You guys remember PEMDAS? Parentheses first. Yeah, I know somebody's going to say, please excuse my dear Aunt Sally. Parentheses first. Okay, that's what we're doing here. 3 subtract 20. 3 subtract 20. Negative 17, it looks like, less than 5. 2 subtract 15. I think that's negative 13. Okay, multiply negative 2 for 102. Less than 5 times 13 is 5, 15, 60, 65.
Hey,
Negative.
Jeff,
Yes.
I think that's supposed to be minus 28, not minus 8 at the end.
Thank you for that correction. Okay, I didn't quite get that far. Almost there, so thank you for stopping me. Yeah, this should be 28. Good catch. Even that, because, well, I'm talking a lot. I'm doing I don't multitask very good. And so you're at home, you probably wouldn't make that mistake because you're working. So that's an excuse. I don't know if it's a poor excuse, but that's my reason. But thank you for catching up. Would be well, maybe you're talking to yourself while you're doing your test, maybe, and you get distracted. Anyway, negative 102. I wonder if that's less than negative 8093. This gets a little weird because both negatives, but that's true. More negative is to the left of less negative. This looks true. It is true. Oh, so down here, I feel pretty confident that's true. And then number line like this. Okay, here's your 4. You go parentheses this way, and then you go 4 comma infinity, interval notation. Okay, Bonnie, I'm going to give you a choice. 5 or 6.
Either one.
Okay, here we go. This is for Bonnie. Eeny, meeny, miny, mo, catch a monkey by his toe. If he hollers, let him go. Eeny, meeny, miny, mo. My mother told me to pick the very best one for Bonnie, and this one is it. Okay, so this is Bonnie. Ah, rats. I was hoping to give you the fraction one.
You could have just taken it.
Crazy, huh? Okay, this one here, LCD. That's just what I would do, which is 12. Okay, so I'm going to put a 12 next to all of it. So 12 next to the x over 2 plus 12 here, 1 over 6, less than or equal to 12. And that'll make the denominators go away and make it a simpler problem. So that's 6x, 2 less than or equal to 2x, and 6 if I haven't made a careless mistake. Yeah, 12 over 2 is 6. That's 2. Yep, okay. So subtract 2x. Subtract 2. Bracket goes less than goes this way, and so we got a negative infinity to 1 bracket. Answer. That almost looks like a square. Optical illusion. It's a 1 bracket. Yeah, that's funny. 1 and then bracket. There, it's better. Okay, then there's a part of this section. Part of it talks about compound inequalities. Now, actually, these are not compound, but these are a little unusual. I'll show you what happens with these guys and what to do. But after this next page, compound inequalities, you'll see how they're different. But if I looked at either one of these, notice that the variable is going to go away. If I looked at both of these, the v is going to go away and the x is going to go away. It's what happens once they go away and how you respond to that. So these will go away, and I'm left with 4 is less than 1. And ask yourself, is that true or not? Of course not, not in our world. 4 is not less than 1, it's bigger than 1. So I would say, oh, but this is not right. Mathematically might say, hey, that's false. False means no solution, means no solution. You can't find anything that will be true. In like manner over here, if the b's go away and you go 3 bigger than or equal to 1, of course that's true. True. True means everything works. Means everything. Okay, well, another phrase mathematically wouldn't say everything. You might say all real numbers. That's probably the best. Or infinite solutions. That's another mathematical phrase. So I'll say all real numbers. So a couple quirky ones. You might get 1 or 2 in your homework. Okay, so these are the compound. Compound mean you've got 2 inequalities and the variables in between somehow. See the variables in between, somehow. These are called compound. So Bonnie, choose. Don't say, I don't care. You like odd or even numbers. There you go. Odd or even. Bonnie, odd or even. What do you feel like to odd or even?
Yeah, I don't know. I'll have.
Okay, hold on a second.
This is getting tricky here.
Barbara, you pick for odd or even.
How about 1 odd, 1 even? 2 and 3?
Okay,
All right, I'll have 2 and 3.
Okay, there you go. All right. There you go. All right, so the strategy is to keep the variable in the middle. That's the strategy. So keep it there in the middle. So if you thought about if I had it without the extra inequality, the process would move the 1 first. Agreed? Move the 1 first. If I didn't have this part over here, move the 1 first. That's makes sense. What if I had this? Now it's a little different thought process, but couldn't I move the 1 first? Couldn't that be an option? Even though you say, Jeff, you're supposed to have the 2 on the left-hand side, but just think about it. Isn't it okay mathematically to move the 1 first as well? And the answer is yes. So what you're going to do is get rid of the number that's not attached to the variable by multiplication. Move the 1 first. Well, this is going to be an easy one for Bonnie. There is no move something first. There's only one thing to do in this one. Move the 1 first. Put a bunch of 1s up there. Anyway, move the 1 here by adding 1. Okay, now you have to add it to all 3 regions. I say 3. There's 1 on the outside, that's region 1. In the middle is region 2. Outside is region 3 over to the right. So add 1 to all 3 places. And then you're going to get -2, simplified, -2, 2x, 6. And then your next step would be get rid of the 2, like manner. Get rid of the 2, but all 3 regions. Get rid of the 2, not -2, but 2. 2, 2, 2, because you're trying to get the x by itself in the middle. So -1 less than x less than or equal to 3. And then from here, the graph might look like. So -1 is here, 3 is over there, answers are in between. The answers are in between. That's what you do, in between. So what do you put on the ends here? Well, no bracket here. This will be a parentheses and that will be a bracket, and they look at each other. the parentheses and brackets look at each other to keep it like, here's your answers in between these guys. And then interval notation comes off the graph. You go -1, 3, and bring down the symbols, parentheses and bracket. That's your interval notation. Okay, my number 4 down here. Same idea. I'll subtract 1 here, but everywhere subtract 1, subtract 1. So I'm left with -9, less than or equal to -2x, less than or equal to 4, and get rid of the -2. Now it's not adding 2, it's multiplying here. Divide by -2. And again, that Will Robinson comes in. Warning, warning, red flag, red flag. Not because it's red pen, but because there's a -2. Divide by -2, because I'm dividing by a negative. That symbol right here has to move this direction. And this symbol in like manner has to move this direction. And you're left with x. You have -2 here, and you got +9 halves. A little backwards. Some of you are saying, I'm uncomfortable with this because you got a bigger number on the left and smaller number on the right. Ultimately, it won't make a difference because if all we're asking for is the graph and interval notation, if that's all we're asking for, then you just have to put your numbers on the number line in the correct position. So negative would be over here. Positive, this is 0. Positives right here. So just put your numbers on the number line in the correct position. And then X is in between. All the answers in between. They're both brackets and have them look at each other. And then the graph is good. Then do interval notation. Because if you do it the other way, like backwards, you do interval notation first and then the graph. Here's what I see as a mistake. Here's what I see. They look at this and they'll go 9 halves, comma, -2, and they go bracket. I get that. They leave it like that, and that's not correct. We read left to right in this country on a number line. We go from smaller to bigger. That's what we do. So bigger to smaller is not acceptable, let's say by me. No, not acceptable. So you got to reverse, and you won't find this as one of your answers on the multiple choice test. You're going to find this one. So that's why I'm telling you, do the graph first, then the interval notation. Don't do it the other way around, because then you're less likely to make a mistake. This is not right. All right. Okay, then in P9, it's a pretty decent sized section if you think about it. I just did inequalities, which was 150. That's all they would have seen. And probably in my intermediate algebra class, probably, which would have been the old 155 when I taught it, I probably would not have done, I'll take that back. No, actually I do it. No, the next part with the absolute values is done or was done in my 155 class. So really what I'm doing on both parts is a 155 concept. The first part was we did, well, I'll even show you. Here's my 150 class. Here's my 150 class. I just don't do absolute value. We don't do absolute value in 150. I repeat this in my 155, and then I do absolute value like I'm doing with you guys. So this might be a little new for a few of you, again, the absolute value. Bars are down here. Most of us are familiar with the bars and have forgotten what does absolute value do. It turns every number that's in here, every real number, let's say -3 here, turns it into its positive counterpart. So if I did, let's say 2/3, absolute value 2/3, it's still 2/3. So absolute value really talks about a distance on the number line to a particular number from an initial point. I'll say that again. It's the distance from 0 to -3 is 3. The distance from 0 to -3 is 3. The distance from 2/3 to 2/3 is 2/3. I'll say that again. I said it wrong. The distance from 0 to 2/3 is 2. They're both positive. Distance is positive. Okay, this one's different than these two here. This one's an equal sign. So there's specific answers for this. If there isn't even an answer, there's specific answers. Tends to be with an equal. You have 3 choices. There's no answer. That's a possibility. There's no solution whatsoever with the equal. There could be one answer, exactly one, or exactly 2. So there's 3 scenarios for this one. No answers, not the number 0, but no answers, 1 answer, two answers. And I'm going to show you how to find them. These 2 here will have infinitely many answers. This will have interval notation required. No interval notation for this one. Interval notation required for the inequalities. I have to show you how to do that. So lots of answers here, not lots of answers, just 1, 2, or no answers. Now, I've written down a certain process that I feel is helpful. Your author doesn't do that in great detail. And so I'm going to try to follow, I will follow my steps for the first few, 1 step at a time, so you get the feel what's going on. And yeah, at the end, set builder, graphing the number line, interval notation. This is similar to what we've done already. Okay, so if I start off with this one, I know all of you can come up with one of the answers that'll work. I know that. I know that first number that comes to probably all of your minds is 7. 7. 7 minus 3 is 4. Done. 7. Now, there is another answer that's a little obscure and not a lot of you can see it quickly or saw this one first. What's another answer that will work here other than 7?
-4.
-1's right. If that was Zach, that's right. -1. Now, that's the one that's a little harder. So there are 2 answers. Watch, -1. -1 subtract, and maybe someone said -4 at the end. You can't plug in -4 because you get -7, absolute value -7 is not 4. It's plugging in -1, which gives you -4, which will give you 4. So just from guessing, guess and check, hey, 7 is one of the answers, -1 is one of the answers, done. I'm going to go to the steps up here and show you how this works, even with the equal sign, Bonnie. I don't know, did you take my 155, Bonnie?
I did not. I don't think I had this since. I just jumped in at PreCalculus, so I missed a lot of that preparation.
I spend a lot of time because we have time in 155 to go over something that's new. And I'm probably spending a little more time than necessary for me. But since I have time today, and it's only one section, I can do this, to go through my steps to help you understand, hey, how to find the answers. So step 1, this is what I did. Write down the statement without the bars. Okay, that means write this down, no bars. So x subtract 3 equals 4. Okay, Jeff, what's the big deal? Well, here, step 2, let's show you here. Step 2, write down the left side without the bars, comma. So I'm going to go over here. Where do you put it, Jeff? Put it over to the right, because you're going to have 2 different statements. Each one of these will have 2 different statements. Here's your first statement. Here's your first one. Here's your second or step statement. So the second statement or step says write down the left side without the bars. Okay, so let's x subtract 3. Just take the bars off. Okay. Flip the sign. Flip the symbol. Flip the sign. Flip, 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 flip. Okay. What happens when you flip an equal sign? Equal sign. Oh, okay. Flip the sign. There, fine. And then change the sign of the right-hand side. Whatever it is, change the sign of the entire right-hand side. So change the sign from 4 to -4. And then solve here. Now, step number 3 really doesn't apply to here. Step number 3 doesn't apply to here because there's no inequalities. See, this really is going to be helpful for you guys with the inequalities. This is an equal sign. So you'll get a few of these on your initial homework, but the rest of them are going to be problems that kind of look like these guys, inequalities. So don't worry about step number 3 for the equal one. Go to number 4, step 4, solve. Sure. Look at that. I mean, that's simple algebra. Look at that. There's my answers without guessing. And then for this one, step 5, step 6, and even step 7, all these you don't need for this one. For this one, I just want to demonstrate that it'll work to get to the 2 answers in this case, if you followed the steps. Now, how does it work over here? I'm just going to ask somebody to come up with a number that is true for this, though. Anybody? What number, if you plugged it in, would actually be true? Zach, what do you think? If you plugged in a number here, Zach, and we did the left-hand side, it would still be less than 4. Just any number. Well, any number. 3. Okay, let's try 3. 3 minus 3 is 0. Perfect. Okay, so I'm a little think bubble right here. X equals 3. When I do this process with you, we'll check that and make sure it works at the end as well. Okay, step number 1. Step number 1. Here's your first step. What was it? Write it down without the bars. Okay, step number 2. Okay, well, back up here. Write down the left-hand side without the bars. Oh, okay, left-hand side only. That would be x subtract 3. Okay, what else? Comma, comma, flip the sign. Oh, this one's going to be a big deal. Flip the sign. Now, don't put an equal sign with it. If it doesn't have an equal, you're not going to turn it into something with an equal sign. So you just flip it around. Okay, don't flip it around like here. Okay, like here. Here. Don't flip it around this way because it's the same thing. Okay, so if it's like this, flip it around that way. And then, okay, here, then it says change the sign of the right-hand side. Change the sign, change the sign, change the sign. Oh, make that -4. Okay, step number 3. You're going to put a word in between here. Now, I require this in your group quiz. If you forget it on your final exam, there are ways of picking the right answer without this word. There are ways of picking the right answer. But on your group quiz, if you don't put this word, you're not going to get full credit. And there's only 2 to choose from. It's the word and, the word or. It's one or the other. And or. Makes a big difference. So if you start off with the statement that's greater than equal to, are we starting off that way? No. If you're starting off with this statement right here, oh, I am, then we're going to use the word and. And goes with the less thans or goes with the greater thans. So, okay, so here, this one's going to be an and. This one's going to be an and. This one here is going to be an or. So you need to include the word and for me, for me. Your author will do something slightly different for this and problem, the and problem. He'll do exactly the same thing for the or problem. The author does something slightly different. I'll try to point it out to you in the textbook what page to look at. Okay. Now, step number 4, solve them independently. So solve this independently. You got x is less than 7 and x is bigger than -1. Okay, I see that, Jeff. Kind of looks like this stuff up here. Now, the number 3. Zach gave me the number 3 and it worked originally. The number 3, put it and check it over here. Does 3 fit is true for this one, and is it true for this one as well? It has to be true for both. The word and means both. Is 3 less than 7? Yes. And is it also greater than -1? Yes. So think of the word and as maybe both, meaning they have to work for both. And also when we get ready for the graph, think overlap. Overlap for the graph. When I say overlap, and I'm going to show you what I mean by that right now. Once you get to this stage, you're ready to graph. So this is the way I'm going to teach you. You go to a tutor, they may have been taught something slightly different because they looked at how the author did it. Okay, I'm teaching you slightly different, but we'll get to the same answer at the end if you needed it. I'm going to do each one of these pieces separately. I'm going to do this one first on the number line. Something less than 7. You put 7 over here somewhere. You do parentheses, and you make the arrow go all the way to the left. Then I do this one next. I'll do this separately, so I'll stack it. What I'm going to do is stack it and put it on top of this. Here's -1 here, and I'll put parentheses on that one, go all the way to the right. So here's where this overlap idea. The answer has to be between. The answers have to be between. There's your overlap in red. So the true picture, the graphing picture, isn't that. The true picture is going to be like this. That's the true picture. This just helped me get over here. And then the author, his interval notation at the end comes off this picture, not that one. Comes off this final. His interval notation would look like -1, 7, parentheses, parentheses, like that. So I use this method because most students come back to me and say, this certainly helped understand it better to get to the answer over here than how the author did it. And that's why I keep this method. Okay, the last one here, I'll have to do it on a separate piece of paper because I'm out of room. The last one here. I'll write this down, separate piece of paper. Okay, step number 1. So first step, just like the last ones, and second step like this. Step number 1, drop everything, meaning write it exactly the way you see it without the bars. Over here, do it again, x subtract 3, but flip the sign, change the sign. Flip the sign, change the sign. So your third step is the word. And you're not going to use the word or and, excuse me, you're not going to use the word and, it's going to be the word or. And is the overlap, or is not overlap. So think of it that way, not overlap. So and is the overlap, or is not the overlap. Solve these independently. Graph them independently. So 7 bigger, oh, it goes this way. -1 smaller than that. There is no overlap. So no overlap. Good. Okay, fine. So what, Jeff? Well, that's it. The picture is telling you where all the answers are. Test it out. Okay, pick like 10 over here. 10 subtract 3 is 7, and 7 is bigger than 4. Pick something over here like -100. -100 subtract 3, -103. But absolute value of a -103 is 103. And oh yeah, it's also bigger than 4. So these are your regions that are the answers. And the interval notation would look like this. Start over here, which would be -infinity to -1, parentheses and parentheses. Over here, 7 to infinity. And then what we do is to join these two interval notations. What we do is to join them. You don't use the word or, although you'd like to think that that's what you do. You use a symbol that represents the word or. We're going to use this U for union. That symbol is called the union symbol. Union. S-Y-M-B-O-L. Some of you remember maybe from another type of math class, there's an upside down U also out there. That means intersection. That means overlap. That implies the and word. So and intersection go together somehow. I'll never use the intersection in our course. There's no need. But the union is necessary. You're going to have the union as part of your answer. So 3 types of problems. I'm going to do a few of them today. Bonnie will do a few others. You just follow the prompts and hopefully you'll do okay. Okay, let's see. Bonnie, you're going to do this one. Let's see. Bonnie. And yeah, Bonnie. You'll do these 3. I'll do the other 3. I'm picking the fraction ones, the hard ones for us. I'm still going to do the steps. So I'm going to ignore the fraction for right now. I'm doing the steps. So step number 1. Okay, write this down. All right, so you go x plus 2 over 2 greater than 6. Step number 2, you're going to go drop the bars, flip the sign, change the sign. And your third step, write the word or, because it's a greater than, you write the word or. Oh, or no overlap on the graph when you're done. No overlap. You want the word or. So likely it's going to go this way. Okay, solve them independently. Well, I'm going to multiply both sides by 2. It's not a hard thing, you guys. You know that. Get rid of the 2, multiply by 2, distribute to both sides. So x plus 2 greater than 12. Solve for x. 10. Bring the or down to remind me. Or. Same thing here. I'm going to multiply by 2. Give it to everything. So again, x plus 2 less than -12. Jumped a little bit. X plus 2 less than -12. Subtract 2. X is less than -14. number line, bigger, smaller, interval notation. Union, done. Test. You want to test it? Good idea to test it. All right, pick something over here that might be like 12. Let's test 12. Okay, so 12 plus 2 is 14. 14 divided by 2 is 7. 7 is bigger than 6. Okay, so it looks like that one worked, and the other one will work as well. All right, this one is different than all of them. This one here is different than all the ones I've done and all the ones that are here because it's got this extra piece on the left-hand side on the outside of the bar. So my steps will not include how do you do this. So if there were a step before step 1, step 0, step 0, move anything on the outside of the bars. The very first thing. Okay, well, there's nothing on the outside of the bars, nothing. Okay, go to step 1. Step 0, move the 5. And that's what I'm doing first. So I'm going to subtract the 5, subtract the 5. Okay, subtracting doesn't change the direction of the inequality. And now we go x plus 2 still, all over 2, absolute value, less than or equal to 1. And now it's a brand new problem. This is where step 1 through, I guess, 7 will occur. So little extra piece to be aware of. All right, step 1, you go x plus 2 again, all over 2, less than or equal to 1. Write the word and eventually. I'll do it now. And then x plus 2 all over 2 greater than or equal to -1. So that's step 1, step 2, step 3. Step 1, step 2, step 3. Step 4, solve. Okay, here we go. So I'll go 2 and 2, parentheses, all this stuff. Distribute. Okay, the 2's will go way here. X plus 2 then ultimately is less than or equal to 2. We're going to bring the word and down eventually, all the way down to the end. 2's go here away, so you go x plus 2 greater than, don't forget to multiply 2 to -1, so -2. Solve. X is less than or equal to 0, and x is bigger than or equal to -4. Number line. Here's 0, and here's, oh, excuse me, -4 is over here. Now, it's an and. I'm looking for the overlap. It's an and. All right, let's see what happens. Okay, bracket goes this way. Oh, yeah. And this one here, 0 bracket goes this way. The overlap is right here. So the interval notation is based on the overlap area. So you go bracket, -4, 0, bracket. That's the interval notation. And if you tested any number in between these, it ought to work for the original. And that's all the way back here to the original with the 5 on the left-hand side. And I'm not going to test it. Now remember, the author, the back of the book, won't have this dual lines going like this with the little shade. It'll have just the bracket with the line connecting the two of them. That's what they'll have. Okay, the last one I'm doing, which I think that might be the last one today. Yep, last one is this one. Now, I can either do this one with the steps, show you what happens, or I can approach it by, and a couple of you actually probably noticing something with number 6. Number 6 is a little different. Okay, what's different? Let's see if anybody recognizes. What's different with number 6? Don't look at number 5. What's different with number 6 in comparison to all the other ones?
It equals a negative number.
That's it. Negative number on the right-hand side. So think about it. How can an absolute value be less than a negative number? That's impossible. Absolute values, 0 or bigger. That's the best you can get. This is going to be no solution immediately because of that statement. And I'll bet you Zach now totally gets it, or he would have said that from the beginning. No solution. Now, the majority of you either not understanding it right now or going to forget on the exam or group quiz. And you're just going to go, oh, but Jeff gave me all these steps. I'm just going to do this. And doesn't it work every time? Yes, it works every time as long as you check your answers. And I didn't check all my answers. I checked a lot of them. So if you remember, check maybe here, number 8. So check something. So you'll find out, and I'm going to do it as if I didn't know that there was no solution. I'm going to just blindly go through these steps, and I'm going to check something and show you it won't work. I'm going to write this down all over again somewhere. How about this one here? Number 6, and then I'll be done. Absolute value of x plus 1 is less than or equal to -4. So I'm pretending I don't know, that there is no answer. I'm just going to say, hey, step number 1 says do this. Step number 2 says do this. Oh, flip the sign, change the sign. Change it from -4 to +4. Step number 3 says a word. So it's either or and, or and, or. Well, it's based on that. It's an and. So overlap. I'm just thinking overlap when it comes to the graph. Okay, solve. Graph. Overlap. Most of you say, well, I'll just do this instead of the 2 graphs. And this is where you're going to make your mistake. You're going to think, oh, I'm done. Or even doing this, -5 to 3 bracket. I'm done. And there will be a version of this answer on the multiple choice test if I can find one. If I found one that has a no solution as the right answer, I'm done. That will be one of the answers because you didn't check. All right, what are you going to check? What's a number between here? How about 0? That's the easy one. Try 0. It's not true. Absolute value of 1 is 1, not less than -4. Yeah, so not true, no solution. No solution. And then Zach, of course, would have said, I'm on to 2 other problems on the, because I knew that one was not no solution. I picked the correct one, and good for Zach or anybody else that was able to determine that and not waste your time because you knew for a fact it was no solution. So Bonnie, you've got a handful, maybe about 6 to 8 problems to consider in your session now for the next half hour to an hour, whoever hangs out. You can work with them on that, or if they have other questions.